Okay. Just when you thought it couldn't get any better, looky there. It got better. Geometric series and sequence. Yes! By now, you're accustomed to working with sequences. And geometric is not going to be really that much different than the ones that you've already done. What makes it a geometric sequence? Well, it's a geometric sequence if we have a common ratio. In other words, some ratio got multiplied to the number 2, and that gave you the number 6. The same ratio was multiplied to 6, and it gives you 18, if this is a geometric sequence. To determine if it's a geometric sequence, you take the ratio of the second number divided by the first one, or the latter element divided by the previous element. So we would have 6 being divided by 2, 18 being divided by 6, 54 being divided by 18. Now, if these all equal the same thing, it's geometric. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So yes, this is a geometric sequence. What about this one? We got 9 divided by 3, 54 divided by 9, 108 divided by 54. 9 divided by 3 is 3. 54 divided by 9 is 6. 108 divided by 54 is 2. No, this is not a geometric sequence. Geometric sequences change by common ratio. Now, there are 2 ways that we can write geometric sequences. We can write them explicitly, and here's the formula. Whatever the element that you're trying to solve for, it equals the first element in the series times the common ratio being raised to the element or the sequence number that comes before this one. So this can either solve for the element that you're looking for, it can solve for the first element in the series, you can even use it to solve for the ratio. Here's the recursive form of a geometric sequence. Whatever element you're looking for equals the one that came before it times the ratio. That's all that this means. So this would be akin to 18 equals 6 times my common ratio, which is 3. That's all that this says here. 18 equals, the one that came before it is 6, so 6 times the common ratio. The common ratio was 3, so 18 equals 6 times 3. Right, here's an example sequence. We're going to use this example sequence, and this is in your notes. And we're going to write the explicit formula and then the recursive formula. For the explicit formula, I need to know the first element and I need to know the common ratio. So the first element is 4. A sub 1 equals 4. Now the ratio. I'm telling you this is a geometric sequence, so you're only going to have to calculate one of these to get the common ratio. So 4/3 divided by 4. 4/3 divided by 4. When you're dividing a fraction by another fraction, you flip this one upside down and you multiply. So 4/3 times 1/4. On the diagonal, these two cancel out. equals 1 over 3. Now I have the first element is 4. I have the common ratio, 1 over 3. So the explicit formula is a sub n equals 4 times 1/3 being raised to n minus 1. So if all of a sudden I had to find, 4 over 3 was the second element. So if all of a sudden I had to find a sub 3, it would be 4 times 1/3 times this number minus 1 squared. And then I'd type that in my calculator and solve it. 1/3 squared is 1 over 9. 4 times 1 over 9 is 4/9. Looky there. Third element. If I needed to find the 100th element, as long as I knew the 99th, as long as I knew this number right here, I could calculate it. Alright. Using the recursive formula. Let's try it again. If I want to find a sub 3, it's going to be the value that came before it. So here's the number I need to find, a sub 3. I need to use the previous amount, 4 over 3, and multiply it times my common ratio. So a sub 3 would equal, multiplying fractions, it's the top times the top, the bottom times the bottom. 4 times 1 is 4. 3 times 3 is 9. And that's how you can use the recursive formula. Both give you the same answer. Alright. Okay. So maybe, let's see here. How to find the common ratio, how to write the explicit formula, recursive formula, how to find a number in the sequence. We found that. Okay. How to find explicit and recursive formulas when you know two elements in the sequence. We're going to look at two cases, just like I wrote in your notes. When you know what the first element is, and then when you don't know what the first element is. Alright, so in the example, I used a sub 1 equals 5. And a sub 4 equals 5 over 216. So this would look like this. A sub n equals 5 is the first one. I don't know the second one. I don't know the third one. But here's the fourth one. And now I need to write both the explicit and recursive formulas that make this sequence. Okay. So I know a sub 1. A sub 1 equals 5. So I've got that part of it covered. What I don't have covered is the common ratio. The ratio is going to come from 5 over 216 being divided by 5. But now I have to take a root of this because these two elements are not right next to each other. They're not consecutive. They're spaced out. This is the fourth one. This is the first one. This thing is growing exponentially. If it's growing exponentially, then to get down to what I need, the root, then I need to take a root. The power of the root is going to come from, this is the fourth element, this is the first element. The space between them is 4. Take away 1, 3. I need to take the third root of this ratio. So let's clean this up a little bit. The third root of 5 over 216 being divided by 5 is the third root of 5 over 216 times 1 over 5. That cancels out, that cancels out. Equals the third root of 1 over 216. Now you're going to do this in the calculator. You could have done it from here. You could type this in the way that it looks here into your calculator, and you'll get the same answer as if you type it in this way. And we're going to do something, I know we can go to math, and right there is the third root, but it won't always be the third root. What we want to use is the fifth one, because sometimes you'll have to use the fourth root, or maybe the fifth root. I don't know. So how do you do that? Whatever the value of x is, the power of the root. So this one was 3. You have to type it in before you push the math button. So let's go back. 3, math, that's option number 5. So 5. You see how it put the 3 right there for the power. And now I'm just going to do it this way. 1 divided by 216. Enter. Math, enter, enter. My common ratio is 1 over 6. Ratio equals 1 over 6. So I've got the first element, I've got the common ratio. My explicit formula then, a sub n equals a sub 1, which is 5, times my common ratio raised to n minus 1. My recursive formula, a sub n equals a sub n minus 1 times 1 over 6. And that's done. Absolutely done. Okay. Now, what happens when you don't know the first element? Well, you're going to end up solving for the first element, and you're going to use this right here, the explicit formula. A sub n equals a sub 1 times the ratio, the n minus 1. What you will need to know is you'll need to know an element and the one that came before it. You'll need to know the element, the ratio, and you'll be able to solve for a sub 1. A sub 1 is being multiplied to all of this. So if we divide this side by ratio, raised to n minus 1, then we divide the other side by ratio, n minus 1, this cancels out. So a sub 1 equals a sub n, any element that you're want to work with, being divided by the ratio n minus 1. So if you pick the third element to work with, then you'll go find the third element in the sequence. You'll put that number there. The power right here is going to be, since you picked the third element, 3 minus 1, it will be 2. Okay, so let's see. I'm going to use the same example that I put in your notes. I have a sub 2 equals 1/2. and a sub 6 equals 1 over 512. Now, in order to find the first element, I must know the ratio. So let's get the ratio first. Here's two elements in the series. I'm going to take a root, and it's going to be 6 take away 2. 6 minus 2 is 4. So the fourth root, and now it's the latter element divided by the previous element. 1 over 512 divided by 1 over 2. Let's just do the whole thing in the calculator with it looking like this. The power of my root is 4. So I'm going to type in 4 first, then math, then number 5. I've got a fraction divided by another fraction all underneath the radical, so I'm going to use parentheses. Parenthesis 1 divided by 512, close parenthesis, divided by, and then parentheses again, 1 divided by 2, close parenthesis. Now I'm still under the radical. This likely is going to be a fraction. So I'm going to tell the calculator to give me the answer as a fraction. I have to move out from underneath the radical first. So I arrow over. Now I push math, enter, enter. And it tells me that my ratio is 1 over 4. 1 over 4. So there's my ratio, 1 over 4. Next, I need to solve for a sub 1. What was the first element in this series? I'm going to use this manipulated formula right here. I got it from just the general explicit formula for geometric sequence. I solved it for a sub 1. Here's my ratio. I get to pick either of these two elements to work with. I can either work with this one or I can work with this one. I don't care. I need to know that number, and I also need to know its index number. Let's just use this one here, the 1/2. It's smaller than 1 over 512. Either one will give me the same answer. I'm going to plug it in here. So a sub 1 equals. So I need the value in that element, 1/2. Being divided by, now my ratio was 1 over 4. Being raised to this element's index minus 1. Well, the index number for 1/2 is 2. So what goes right here is 2 minus 1. Simplify a little bit, so 1/2 being divided by 1 over 4 to the first power. 1 over 4 to the first power is just 1 over 4. So 1/2 divided by 1/4. 1/2, 1 divided by 2, divided by 1 divided by 4, enter, 2. The answer is 2. My first element is 2. A sub 1 equals 2. Now I can write the explicit formula. It's a sub n equals a sub 1 times the ratio raised to n minus 1. So a sub n equals, I'm going to replace a sub 1 with 2. I'm going to replace the ratio with 1 over 4 and then n minus 1. This is the explicit formula. Now the recursive. It's a sub n equals a sub n minus 1 times the ratio. So a sub n equals a sub n minus 1 times 1 over 4. And that's it. That's the recursive. Okay, so what do you do if you're given some elements and you need to find the ones in between? In the example, I used -4, blank, blank, -500. To find these two, we're going to have either the explicit formula or the recursive formula. And what we need to know for both is, what's the ratio? Now, I don't know where in the series that this comes along, because right in front of it are these, which means that there's more of it to the left. This would mean there's more of it to the right. But I can take just this part right here and work with just it. So I can call this a sub 1, which would make this a sub 4. So already I know that a sub 1 equals -4. Now my ratio is going to be this divided by this, but I'm going to take the root of it, and the power of the root will be this number minus this number. 4 minus 1 is 3, so the third root of -500 divided by -4 equals. Well, automatically this turns into a positive. A negative divided by a negative is a positive. But we'll just type it in the calculator that way anyhow. So here we go. 3 math 5. It opens up the third root, and now I can type in -500 divided by -4. Make sure I get outside of the root symbol. Math, enter, enter. A common ratio is the number +5. +5. So how do I find this element? I've got two choices. I can either use the explicit formula or I can use the recursive. Recursive turns out to be the easiest one to use if you know the value that comes right before this one. The recursive is a sub n equals a sub n minus 1, which just means the number that comes before this one times the ratio. I'm looking for a sub 2, so it's going to be a sub 1, which is -4, times my ratio, which is 5, -20. So what goes here? -20. Now that I know this one, I can use the recursive formula again to find this one. A sub 3 is going to equal a sub 2, which is -20, times 5 equals -100. -100. And that's how you will find the elements that are missing. Missing terms. Okay, I think that's all that you need to know to be able to do these. You have your assignment. Look the notes over. Watch this video. Watch this video as many times as you need to so that you can do the work. Stop it. Watch the part that you're working on your worksheet. Stop it. Play it again if you're still not understanding, but you can do it. And then you also have some exercises in the book to do over the same thing. Anyway, I hope things are going well with you. I miss you guys. Don't let your head hang down. Lift your head up. There's plenty of things to be happy about and thankful for. Let's just finish this year strong. And then 30 years from now, you can be bragging to your grandchildren how that you had to learn on your own at home, but you stuck with it and you got it done. That's going to be a whole lot better telling them that than telling them, I just didn't care and wanted it to be over with. All right? So stick in there. Get it done. Look forward to seeing your work. Bye.